My voice is audible?
Yes, sir.
Okay. Tell others to join immediately. What was the strength for previous class? Mahesh?
Yes, sir.
What was the strength for the previous class?
42.
Okay. So it's 33 now. So put one message on your group. Join immediately.
Yes, please.
So we have got total 5 examples. 5 examples we have solved. And this one I have given as a So how many of you tried these examples to get the answer?
Shall we start? Only 37 are there. Should others are joining? Chalo, what is the last lecture? Hello.
Yes, sir.
Chalo, what is the last lecture?
Second chapter, sir. Start again.
Okay, we started the second chapter, and I think we have finished with the C2.6, means up to this part, and after that we have, I think, gone with this diagram. Is this correct, na?
Yes, sir. Yes.
Means how this control can be interfaced with the various IO devices, which may be input and the output, and based on the requirement of the user, we can connect or interface the input devices such as sensors, keyboard, joystick, push buttons, and we can control the any output applications such as the various motors, buzzers, displays. Okay, to the 8051 microcontroller. So up till now we have seen, I think, last lecture. Correct, na?
Yes, sir.
Yes.
Chalo, theek. We go to the next point on that. Simple block diagram of 8051. Just draw it. Next point you can write down. It's not architecture diagram actually. It's a block diagram of 8051. What is inside the IC? And if we talk about, we have the two different diagrams. I will show it here only. If you go with this, this is called as a architecture diagram of 8051. How all things are connected. But not visible. I have second one also. This one. Okay. So block diagram is different one, and architecture diagram is different one. Don't make confusion in that. Draw this diagram, and once over, tell me. Screen is visible to all.
Yes, sir.
Okay. Go ahead. Fast.
Next, so I think when this branch, so at this point you can mark this as a IP, or directly I will consider as a case Now, I could not find I fix easily. I fix when it would make that out. When you do that is the one I fix something, I put it into it, and I fix the same. So apply ACS at the ACS at point B. Right. Yes. So incoming current are 2. That is the I4 and this 2. That make it minus. Make it out of the way. Okay. Without the current can
Done. This is over. Diagram is over.
stop plus 1
No, sir.
Okay. Okay. Go ahead, Nish.
I4 can take one side. So minus I4 minus 1.
Suhas Pawar, why were you late? Pawar is there. Suhas Pawar.
So here we can write this is the I3. I3 more.
Over.
Yes, sir.
Okay. Others died fast. From girl side, it is done.
Yes, sir.
Okay. If you observe this, this is called as a basic block diagram of the 8051. Okay. And sometimes question asking for the 4 marks or the block diagram, write the features of the 8051. So what is meaning of features? If we talk about from the diagram, what things are provided in this diagram, that can be each a feature. Each block correspond to one feature of the 8051. So what is meaning of that? First, talk with the size of the 8051. What is the size of this 8051 microcontroller? Okay, so we know that it is a 8-bit microcontroller. 8051 belong to the family of the MCS. Okay, so first feature will be what? 8-bit microprocessor. How to decide that? Depends upon the size of the ALU and the data bus. It indicates the size of the 8051. So what is the data bus I am using here? It is a size what? 8-bit size only. And the ALU, what is the A register is there in that CPU register banks? That is also size of the 8-bit. That's why it is of the size 8-bit microprocessor. What else? Starting with that, what is the other things are there? If we talk about starting from this point, it can support for the different types of the interrupts, such as the hardware interrupts as well as the software interrupts. Okay, so it has the two hardware interrupts, that is called the INT0, INT1. Okay, and other total 6 are there. Out of that, 2 are the hardware interrupts, INT0, INT1, and remaining 4 for the timer 0 and timer 1 to raise the flag. When the time will be completed, automatic flag will be raised. That is TF0 and TF1 for the timer interrupts. 4 are there, and remaining for the serial communication, TI and RI, means transmit interrupt and the receive interrupt. Once transmit will be completed, the flag will be raised on based on that. Okay, so total 6 interrupts are there. 2 are the hardware, remaining 4 are the internal, that is software interrupts are there. Then I can say that it has the CPU. CPU means it has the accumulator in it, that is the size of 8 bit. Okay, then it has the oscillator pins connected. It doesn't have the oscillator inside, but we can connect the oscillator outside, but it has the pins for the connection. If you observe the pin diagram at pin number 17, 18, these are the pins given to connect the oscillator, which varies different oscillator frequencies 0 to 24 megahertz crystal can be connected. But in a specific 8051, we have the 12 megahertz crystal to be used here. Okay. Then if we talk about it has the different memories, on-chip memories, basic difference between the microprocessor and the controller we have seen. So it has the on-chip two memories. First is called as a ROM memory, also called as a program memory. Okay. So it is size is going to be 4 kilobyte of size is there. 4 kilobyte internal ROM memory is there in the 8051. Second, it has the RAM memory, also called as a data memory, and size is what? 128 byte. Try to understand what is the data I'm putting the values. Always the MCA asks on that, so you should understand. The size of controller 8 bit, size of the data bit 8 bit, size of the address bus 16 bit. Then on-chip ROM memory of the 8051 options 4 kilobyte, 4 byte, 16 kilobyte, 64 kilobyte. So option will be 4 kilobyte is the internal on-chip memory. 64 kilobyte can be interfaced externally. Okay. This is the another feature. Then the second feature, what next? It has the on-chip RAM of 128 byte. 128 byte of the on-chip RAM. RAM also called as a data memory. Then it has the two different timers, and that can act as a timer and the counter. That is timer 0 and timer 1. And the size of timer is going to be 16 bit. Okay. How to decide that 16 bit? Because while designing 8051, they have designed the timer size of the 16 bit timer. That's why I'm saying here size is going to be 16 bit. If you use this, what is the maximum count can be counted by the timer? It depends upon the size. So 2 raised to 4, 2 raised to 16, that belongs to the 4 times of FFF in the hexadecimal. In decimal, 65,536. That is the count total can be hold here. If you talk about here, I'll write here 2 raised to 16. That belongs to the 4 times of F. It is in the hexadecimal. Okay. In the bracket outside, I will write the H. That will talk about it's a hex value. And that is equal to always 65,536 decimal value. Okay. Base 10. So that is the count counted by the this timer IC. 2 timers are that 16-bit timer. But it is 8-bit, 2 raised to 8. Try to understand. Here I am giving hint actually how to find, but we are specifically when the point will come, timer counter, we are going to observe that point also. No issue in that. Okay. This is called as a timer delay. To find that timer delay, it is written here.
By taking one example, I will explain how to find out the equivalent.
Okay, once it is over, then I can say that it has the 8-bit data bus as well as it has the 16-bit address bus. Okay, then it has internally serial port for making the communication. Means it can send the data out through the transmit pin from the controller, or it can receive the data inside the controller from the external devices. That's why it has the serial port to which I can interface the I2C bus or SPI communication or the UART communication. So any model of the communication IC can be interfaced here. Then it has that is important 4 on-chip IO ports. It has the 4 ports: port 0, port 1, port 2, port 3. Okay. So all these ports are the multifunctions. Means it can act as a input port, it can act as the output port, meaning is IO. IO means what? Input as well as output. So we can configure. You can see here the arrow indicates the direction of that. So it is a bi-directional. So MCQ is also asking that the port is going to be unidirectional, the bi-directional. So I can say all the 80 ports, port 0 to port 3, all are the 8-bit bi-directional ports. Okay. In that specific key, if you talk about port 0, that port 0 can be used for the configuring the address bus as well as the data bus, including the port 2. So port 2 has the lower address data bus D027, and the port 2 it has the higher added AD8 to AD15 address bus also. Means it can act as the address bus as well as it act as the port specifically. Then it has the bus control, means to control the bus, it acts as the address of data or port. We have the bus control facility inside this 8051. Okay, so from this figure, we have to understand what the 8051 block diagram offers. What are the features that can be offered? Starting with it is 8-bit microcontroller. Okay, it has the 6 different types of interrupts. Out of that, 2 are the hardware interrupts and 4 are the software interrupts. It has the 8-bit CPU or it is 8-bit ALU. Then it has the accelerator facility connected from 0 to 24 megahertz maximum. Then it has on chip ROM memory, RAM memory, 120 byte, 4 kilobyte, 2 timers, 16-bit timers are there. All these features we have to observe from this diagram. We have to write down. Is it clear? Have you understood the block diagram?
Yes, sir.
So write down the please features of 8051. So if you talk about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So near about 10 features can be written as per this diagram itself. Still we have that, we'll go with that features also. Next slide is there. These are the features. Ek at 1. तो अपन बसा. Okay, so as I mentioned that the size of the controller 8-bit data bus is there and 8-bit ALU. First feature, 16-bit address bus, on-chip RAM of 128 byte, on-chip ROM of 4 kilobyte, 2 timers, that is timer 0. I'll write here also, timer 0 and timer 1. So which can be count maximum delay provided 2⁻16. We have written that. It has the one serial port for the serial communication. 4 ports are there, 8-bit wide, bi-directional. And when the data will be longer than 8-bit, we can broken into 8-bit and can perform the data communication. As I said that it has the 5 different interrupt sources, 2-level program memory, lock EEPROM. How to lock that depends upon the EA bar external pins are there. That can be connected to the ground or VCC. If EA bar is equal to 1, it offers the total 64K. Out of that 4K internal and the 60K external, like that. We'll see that specifically when the point will come. Just write down the features now. If any problem from this feature, you can ask. I'll describe that feature properly also. Missing is that it can connect to the crystal oscillator frequency. Oscillator 0 to 24 megahertz can be connected.
That will be totally based on how the current is getting, whether it is dividing or same current will flow. Okay. Now next one. So 4 and 8 are in series. So total resistance will be what?
It has A register, comma B register,
So it will be the 12. Now 6 and 6.
and
Double combination, what is
R0 to R7.
without calculating
General purpose resistors.
Yes, very good. So when two equal resistors are connected in parallel, the answer always will be the half of the resistance value. So 6 in parallel with 6 divided by 6 plus 6. That total will be 36 divided by 6.
Taken. All the features you have taken this.
Sorry, divided by 12. Divided by 12. Divided by 12. That would be what? 4. So whenever two equal value of resistors are connected in parallel, the answer of that parallel combination is always half of the resistance value. It's 7 is the 3, 8 is the 4. Okay, so here 3 will. So again, suppose I am removing this 4, removing this 6. So now instead of 6, 6, now it is 3. Okay. Now, how the above 3 ohm and below 3 ohm are connected now? Yes. Okay. So this 3 ohm and this below 3 ohm, both are connected in series. Okay. So 3 plus 3, what it will be? 6 ohm. Okay. Now the circuit is looking like what? This branch total 6 ohm resistor and this branch total is 12 ohm. Now 12 and 6, how they are connected? Yes. So 12 and 6 parallel combination you have to find. So we can go next point, means they have divided into number of points. So between F and G, between D and E is parallel combination. Next between C and E is series combination, and then
Chalo, have you done this features?
No, sir.
No. You can take in short also. It is not required to write the complete sentence.
3 and 3 are in series now. This 4 and 8 are in.
So you can write here also 4 ports, each a bit wide, also bidirectional. More clearly, we can write all these things. No issue in that. Bidirectional, and which are the ports? It has the port directional. R is missing. P0, P1,
Yes.
P2, and P3, like this.
A and C, this 2 ohm is remaining. So that is not connected in series as it is. Okay. So here D point, D and D and D are same. Between C and E, so the combination now becomes 4. So that is in series with 2 because same current is flowing these 2 resistors. 2 and 4 are in series now. So total resistance calculated here.
Done.
AB is equal to
Yes, sir. Done.
Everyone, girl side, boy side.
Yes, sir.
Mahesh,
find out the equivalent.
Yes, sir.
any problem in that? कुठला फीचर कळालं नाही यातलं सांगू शकता कळू शकता?
I will tell you, take more time, but solve accurately.
Please try to follow the protocol. So as we are discussing meeting, sorry, chodi. Only 5 to 10 minutes students are allowed at the start of the lecture. After that, in between, no one is allowed. So you should find the proper range for the attending lecture. If by chance we have the network issues, but not you should repeat it for every time. Huh. Have you done this? Have you understood the features of 8051? It's important as point of the as we discussed. So each feature we have to go in detail after the in this chapter only. Should we move to the next point?
Yes, sir.
Yeah, okay, good. Here also I taken the features only, but that in that the both things are the same. Okay, so not required to go again on that point. Then we have the next block diagram of the sorry, not block diagram now. Now we have the specific architectural diagram of 8051 microcontroller. I don't next point.
You can understand the type of message.
architecture diagram of 8051. So you should understand what is architecture and what is a block. Block means all these blocks means 4 ports are there connected to the data pin, the CPU. Okay, then it has UART disconnected here to data bus, memory is data bus. But here specifically, what is the RAM, how it is connected, what is the ROM, how it is connected, 4 different ports with the 4 latches. Okay, along with this, how it will be act as an address data bus, that is mentioned here. So that's what's the in detail internal design of the 8051. Also, it is called as the architecture of the internal block diagram of the 8051. Both are correct. Is it visible to all? Should I make maximum? Huh? This is Sarvana? Mahesh?
This day, sir.
Huh. Or should we go to the next slide? This one. Both diagrams are correct. No issue in that. It will go Apanita?
Yes, sir.
हाँ ठीक है हिट हुआ मग इट्स विजिबल एक्चुअली जरा मैं ये डिलीट करतो म्हणजे तुम्हाला इंटरप्ट होणार नाही so this dot dot indicates inside this all things are inside arrow the dotted line externally indicates it's inside also it operates from the 4 to 5 volt operating voltage for this controller. You have to draw all everyone should draw this diagram and I want a screenshot of this before the next lecture. What we have seen from second chapter onwards, I want this.
Anyone got another answer? One? Right point?
At this block also you can write the size of the RAM. 128 byte RAM is there. And this is called as the ROM. Flash memory means it's a flash means what? It's a ROM memory 4K.
Sufficient to solve this exam. If your calculator, then it will become.
I will tell here what is the name written here. So it's a timer and control, timing and control. First block, timer and control, timing and control. Second, instruction register, shortcut INS register, instruction register, or it is called as an instruction decoder.
How three are connected? Series of parallel. Okay. So 3 and 5 are becomes 8. So 8 is in parallel with 4. 8 is in, because this current will be different and this current will be different. Both currents will be different. Okay. So that's why these two currents will be different. This branch and this branch are parallel to each other. But whatever this current is there, that will be the same. 3 and 5 are in series. So that is plus 8. 8 is in parallel with 4. So I will mark here direction to which I am going to send out the R area. First of all, this is the way of writing. AB equal to. Okay. So 5 plus 3. That will take in the one bracket. But both are in series. That's the addition. 5 plus 3. That will be the in bracket. That is in parallel with 4. So this answer I
Make
will
it fast.
find out first. Okay. RAB is equal to in bracket 5 plus 3 in bracket. That is parallel with 4. That is in series with this 4.
If something is not getting, you should ask me. I'll repeat that point.
And like this.
In a device name, all these things, if it is not understood, please ask.
So I will make a sublimation here. That is in parallel with the last two. So one by one we can solve it. That is continuity. So 5 plus 3, that becomes 8. 8 is in parallel with 4. That we can solve. 8 into 4 divided by 8 plus 4 is 12. That is in parallel with this series with this plus 4. That we can see that is that parallel with 2 plus 3. Okay. Now next one. 8 plus 8 into 4
It's
is
a
what?
programmer. It's a POR, not. It's a PRO. It's a program address register. Then buffer, PC, incrementer, program counter, DPTR.
State-wise you can go. If calculation becomes easy and you can get the correct answer. Now, here nothing is 1 is there always in the denominator. Take the cross multiplication and get 8 into 1 means 8. 3 into 4 means 12. So 12 plus 8 means what? 12 plus 8 means 20. So 20 divided by this denominator multiplication and 8 into 4, 1, that is 8, plus 3 into 4, that is 12. 8 plus 12 is 20. Divided by 3 into 1, that is 8. Now this is the answer of this bracket. Now that is in parallel with 2. Divided by 3 is parallel with 2. So that answer we have to find. Now to find
This is
out-
XTAL1, XTL2, means pins for the crystal oscillator connection.
So numerator 2 by this is solve the denominator. Start somewhere here. So this will become 40. Numerator
Over.
2 divided by 3.
No, sir.
Hello, have done this?
No, sir.
Okay.
Again take the cross multiplication. 20 into 1 and 3 into 2. That is the 6. So 26 divided by 3 into 1 is 3. 3-part block. So P and P will get cancelled. P and P will get cancelled. 40 divided by 26. 50 divided by 26 start in the
So this was the program store enabled.
20 divided by 30. 20 divided by so how many of you got this answer? 5.14, that is a round. And here someone made the mistake. Denominator becomes correct here, but numerator is same. It is like this. Do you understand now? In this way, you have to write in the answer sheet. First of all, how the registers are connected, that you have to write in a one line. How the registers are connected to each other, you have to write in this way. But you have to observe how up to this. 5 plus 3, and that is in parallel with 4, that is in series with 2, and that is in parallel with 2. Then you can solve one by one bracket, and after that you can get the value. Everyone note down this? Everyone note down. Now take the snapshot, and after that you can study. Okay. Yes or no? Understood? Then you can solve one more example I will do. Try to solve. Find out the equivalent resistance between A and B points. I think you have to find it. Now you can add it to the simple one.
Over.
Yes, sir.
Okay. You should tell it now. Once or I told that once you have finished, you should tell them you are done with that. Okay. So this is the internal block diagram of the 8051. And as I said that features or on-chip devices, if we talk about the microprocessor and the controller, microprocessor has only that ALU part and the registers only. Other things it is not there, neither ports is not there, stack is not there, RAM memory, ROM memory, all things it is not there, or this PC program counter. Okay, only it has that CPU in it along with the register banks in the microprocessor. But whereas if we talk about the microcontroller 8051, it has on-chip various devices. Okay, and how they are connected to each other to perform the operations or the tasks, it is shown in the architecture diagram. Always starting with the what? First point, that is called as ALU. Okay, and what is the ALU? Arithmetic and the logic unit. So what is function of this ALU unit? It performs the various arithmetic and the logical operations. What is arithmetic? Means addition, subtraction. So addition of 8-bit, 16-bit, subtraction of 8-bit data, 16-bit data. Okay. And the logical means what? if I want to do the ORing and XORing of the operations of the data, that is performed by the this ALU unit. Okay, and based on the result, if it says that simply, it is performed the 8-bit size is the 8-bit. If the addition is going to be overrides, it has the PSW registers, that is called as a program status word. In that we have the various flags that can be raised depends upon the result of the ALU. I'll explain here only. We'll go in detail afterwards. Okay. Then it has the accumulator, means it is called A registers. So after every ALU operation, either subtraction, addition, or XOR operation, this ALU, sorry, accumulator means A register, the size of 8-bit, always hold the result of that. Okay. And depends upon the result that ALU can or control can take the action. Also, along with this, it has a temporary B registers, like same accumulator A register, B register. So both sides is going to be 8-bit. Okay, ALU 8-bit, accumulator 8-bit, and B register also 8-bit. Then, as I said, that it has the 128 byte of the internal RAM, and to increase the address of that means starting with the 008-bit. Then I want to go with the next address. We have the address increment registers. That is the RAM address registers that will be incremented and will go to the next memory location. Okay. Then it has the flash memory, means it is a ROM memory. Internal ROM memory is there of the 4K byte. Okay. Along with this, if we talk about we are in the memory only, then it has the stack pointer also. So what is function of stack pointer? The size of the stack pointer is going to be 8-bit only. As I said that when the interrupt will be occurred, this ALU means control want to store the what was the program going on in the sub memory location. Okay. So when the interrupt occurs, what was the current address, memory address, it is stored in the stack pointer, and after that it go for the that ISR execution. We'll go with the flow chart, flow diagram. Once that point will come there, just understand here stack pointer function is what? Store the temporary memory address by using the two instruction, push and the call. Push means what? Keeping in that address in that. Call means call the that memory address where we want to start the action. Okay, so this is the memory address I can say, or registers. Then it has the 4 ports: port 0, port 1, port 2, port 3. Along with that, internally, all these 4 ports are connected by using the latch. That is a driver, I can say simply. Okay, and specifically, we want to go with the all the 4 ports internal diagram of that. How to read this port 1, how to write on the port, how to act as the output. All these things, 4 ports we have to see specifically. So 4 ports means what? 8-bit wide, 8 into 4, 32-bit. So out of 40 pin IC, this 805 has the 40 pin IC. 32 pins are for the IO ports only. Out of 32, then remaining 40, 2 for the crystal oscillator connection, 34. Then 2 for the PCC and the ground. That becomes 36. And the 4 pins act as the control pins. That is mentioned here. PS enable, ALE, interrupt external access, and the reset. All these 4 pins are there. So total 40 pins are there for that. Okay. As I said that port 0 act as the IO port input as well as output. Along with this, it holds the lower address bus that is connected to the address ledger. Means it acts as the AD0 to the AD7. AD means address data register, that is the multiplexed buses are there. Address as well as the data that is held by the this P0 to P7 means port 0. So we can understand that what this address register means what? Address bus is there, and that is connected to the port 0 and the port only. All this it is not connected to the port 3 and the port 1. Okay. Why? Because this port 0 act as only multiplexed lower address AD0 to AD7, and port 2 act as the higher address A8 to A15. That is port 2. Okay. And this port 1 and port 3 simply act as a input and output port. And port 3, it is a multiplexing. Along with it acts as the control. These control bits are there along with this. That is timer control, interrupts INT0, INT1, and the serial communication TI and the RI. Once we look at the pin diagram, we can understand this. Then if you come here, it has the program address registers. So it has the 16-bit address. Always it's going to be incremented, and that address will be goes to the particular port 0 and port 1. Then it has the internal buffer, that is called temporary storage. Okay. Then it has the PC incrementer. PC means program counter, and the function of this program counter register 16-bit wide always hold the memory location or memory address, which is next address of the instruction. For example, presently the controller is operating with the memory address 8000. Okay. Then in this PC counter, the memory location will be 8001 will be there. Means always hold the next address of the instruction by the PC. Means meaning is that we want to go to the after execution 8000 memory location. What should where to go the controller at the address of the PC hold by, that is 8001. That is function of the program counter. Then it has the DPTR. Okay, under this it has the two registers, DPH and DPL. It is called a data pointer register. And also it is going to be 16-bit wide. Okay, it has a DPH as well as the DPL. Each hold the 8-bit data, and this specifically used to access the external memory data access. Once we interface the external memory, and from that memory I want to take the data inside the controller. So by using this DPTR register, we can take the data in and we can send the data out also. Okay, so this is simply internal code of that. So we'll go with the specifically the function of each and every block. Okay, we'll be starting with the memories. It is written here. It has the internally ROM memory of 4 kilobyte. As I said that 4 kilo means starting with the address 4 times 0 to the 0 FFF 3 times FH. This is address of the ROM 4 kilo internally. Okay. And function of this program memory is what? Always what is the code we are written, it goes to store to the that memory location. Along with this 4 kilobyte, we can connect the externally 64 kilobyte of that memory based on the condition that the EA signal, either it is VCC connected or ground connected. Then it has 8-bit register widely in the, that as I mentioned, arithmetic and the logical operations for that. It also has the B registers. Same function can be done like a register, that is accumulator. Okay, next point will be the in that internal diagram. If you observe the PSW, so as it said that what is the exact present location of the ALU? It is shown in the this PSW registers. So what is the meaning of that? Program status word. That is meaning of PSW. Means after the execution of the certain instruction, it may be the mathematical or it may be logical. What is effect of that result on the flags? It is indicated in the program status word registers. It is 8-bit wide register and always give the status of the ALU. I mean, what is the result and what is the action we have taken. Okay, starting with the bit 0, bit 0, bit 1, bit 2, 3, 4, 5, 6, 7, like that. If you go with the bit number 7, it indicates the CY, means what? Carry flag. For example, if you talk, I will take here only, I will show. I need to insert one text box here. So I have the R0 is equal to data 1, 1, 0. That's 1, 0, 0. So I'll for simple I'll take 0, 0, 1, 0, 0, 1, 0, 0. So it is going to be 8-bit wide. This is in the binary format. 0 bit 1, 2, 3, 4, 5, 6, 7 means 8-bit wide. Same time, I have the R1 register contains. I will take its 1, 1, 1, 0, 0, 0, 0. All I'll take the 0. Okay. If I will add this data What is the action? I'll take it. Who did the 8-bit addition? कौन perform करते हैं? कौन सांगते हैं मला 8-bit addition है? 0 XOR काय असलं तर 0 into 0 0. I'll take that. This 0 into 0 0. This 0 into 0 0. Then 1 into 0 1. Sorry, it's 1. Then 0 0 here 0. Then 0 0 again 0. Then 1 0. It will be 1. And at this point, if I add this 1 1, going to perform XOR operation. What will be there? 1 XOR 1. What is the answer? 0. But we have the carry flag. I'll be writing the CY. CY is equal to 1. Where it goes? This result will be shown by in the accumulator. Where? In the A register, I can say. Okay, the A register will hold the this data 0 1 0 0 0 like that. But what was the carry generated? Where it goes? It goes in the our PSW register at the bit number 7. Now you understood this? Means once upon the instruction executed, what is the action result? If it is exceeded or some result is different, then it is indicated in the program status register. That is PSW. So bit number, this bit once for this result, the bit number 7 will be 1. This will go to the high. Once this bit is going to be set. Clear? कळला तर सर्वांना? Is it clear?
Yes, sir.
Okay. Then bit number 6 is called as a auxiliary carry. AC indicates auxiliary carry flag at bit number 6. Same meaning like carry flag only, but it shows the result when exceeded for the 8-bit result. And if you talk about this, if it is 4-bit result, this is for what? 8-bit. And for the 4-bit, if the carry is exceeded, it will show by the this flag. I like this. Means if you do the addition, 0-bit 0 0, 1-bit 0 0 0 0 0 0, but 1 plus 1, it will be 1 XORing 1 1, sorry 0, and the auxiliary carry flag at the 4th bit number will be raised. So when this kind of addition will come, means for the we can say nibble, lower nibble, upper nibble, that form the 4-bit, 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 8-bit will be formed by the accumulator. But when we're doing the 4-bit addition and the addition will be exceeded, that time carry will be generated. That indicates in the auxiliary that flag, carry flag. Okay. Then we have the user flag F0, that is indicating the bit number 5. Flag 0 is available for the user only. That is not mentioned for its application now. Okay. Then bit number so 6 5 4 and 3, that is for the register bank selection. As I mentioned that we have the 4 register banks in the 8051, that is bank 0, bank 1, bank 2, and bank 3. So based on this value, if it is 0 0, by default bank 0 will be there. If 0 1, bank 1, 1 0, bank 2, 1 1, bank 3. It is mentioned here. As it is 2-bit bits are there, bit 3 and bit 4, 4 and 5. So based on that, I can say 4 possible combinations and for the 4 banks with their address which is given here. If you talk about R0, R1, 0 0 bit, by default bank 0 will be selected. Then 0 1, bank 1, 1 0, bank 2, and when the all ones are there, that time bank 3 will be selected. Okay, and address is starting with the 00 to the 07. That is 8-bit address for the first bank. Second 808 to the 0F. Second 8-bit for the bank 2. Sorry, bank 1. Then 1H, that is starting with 16 in decimal. 10 to the 17. That goes for the second bank. Means total this value 00 to the 1F means it is a 32-bit value is there. 00 to the 31 in the decimal. Okay, and this is for the bit number 3, that is overflow flag, that indicates bit 2. Okay, so overflow flag means what? Whenever any register's value exceeded beyond its value. If you talk about accumulator size is going to be 8-bit only, or register R0 size is going to be 8-bit only, and we are accessing the data of 9-bit, 10-bit, or any greater than that. That time, this flag will be set here. By indicate the result is going to be overflow. Okay. Then bit number 1 is going to be reserved. It is not used here. And 8051, it can keep to the future scope. Then last bit number 0, it is called as the parity flag. Parity means what? Either it is a even parity or parity. How to find? In that result data value, how many ones are present? Based on that, I can find out the it is 1 bit or the even parity or parity. Meaning is that I'll go with here. When I'll use this R0 is equal to this data 1000100. It indicates what? How many number of ones are there? Even number of ones are there. Indicates that it is a even parity. If in that bit only I'll make this, it is 1, means it has the 3 ones, it is odd number. So it can indicate the odd parity. Okay. And how to state in that? Even parity is set by the 0 flag. So when the data is accessing that 1000 means only even ones are there, 2 ones are there, means this bit is going to be 0, indicates the even parity. Okay, indicates the odd even parity based on the bits 1 is an accumulator. And if 3 ones are there, that time this bit will be set 1. That becomes bit 1, indicates the odd number of bits will be there. It may be 1, 3, 5 like that, or 7 also in the bit data. Is it clear? Everyone, this what was the 5 flags are there, 5, 7 flags, how it give the status of the ALU. Hello. हे कळालं का सर्वांना? Hello.
Yes, sir. Yes.
So take this for 2 minutes and you can draw this fast. Then we'll stop it here. Or will you take the screenshot of this and we'll draw it? Which way? काय करता? Huh?
Screenshot घेतला sir.
But you should look in the notebook, and you have to send the screenshot of that.
Yes, sir. Yes.
Chalo, ठीक. Take the screenshot and do as homework. And if not understood, we'll see in the next lecture also the remaining part of that. Should I have taken the screenshot?
Yes, sir.
Okay. Then we'll stop it here. Time is up for our lecture. Chalo, you can put it attendance now. I can take from here also. Remember 3 is absent. 1, 2 is there. 3 is absent. 4, 5, 6, 6 is there. 7 is there. 8 is there. 9 is there. 10 is there. 11, 12, 13, 14. Today I'm taking like this only. I want to see who is attending, who is not attending. 15, 16, 17, 18, 19 is there. 2, 0 absent. 3, 2, 0. 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8, 2, 9, 30, 31, 32, 33, 34, 34, 35, 36, 37, 38 is not there. 39 is there. 40 is not there. 41 is not there. 42, 43, 44, 45, 46, 7, 8. 49 is not there. And 50 is not there. Correct, na? So number absent 3, 20, 38, 40, 41, 49, 50. Correct, na?
Yes.
Okay. Chalo, thank you.